Well, hello guys, Mr. G here with another video. Today we are going to be working for the grade 10. We're going to making a test or answer a test for the grade 10. This test is a term 1 test related to wave, sound and electromagnetic radiation, and it was a test done in one of the high schools, which is the William Prescott High School. Alright, now before we start, remember to subscribe for the channel so you can get all the notifications and the videos and so on a regular basis. But now, without taking more time, we're going to start with question 1, which states the following diagram shows two approach pulses. Then you have two pulses, one at the bottom of the rope or whatever medium it is, and one on top. Now the first question is define a pulse. Alright, and pulse where all the particles move perpendicular to the direction of the propagation of the pulse. The particles move perpendicular to the direction of propagation of the pulse. There is a video on this topic. I'm going to leave the link so you can watch it if you don't remember. Let's say these are particles in the medium, and those particles, all of them are going to move perpendicular. For instance, this pulse is moving to the left, so the particles are going to move in this direction, up and down, but the pulse itself is moving in the perpendicular direction. Okay, so this is what we mentioned of what it is a transverse pulse. That is the definition. What type of interference will take place as a result of the superposition of the pulses, one top, one at the bottom? Then they will have the destructive interference. There's also a link on this one, and I will leave the link there because you need it for question 1.3. Now draw the diagram in which you show the type of interference that took place when the pulses meet, just when they meet. So what are we going to have when they meet? Now when these two pulses meet, they will cancel each other, and it will result in a smaller pulse down here, which is only 1 centimeter. So this one here will be 1 centimeter of amplitude, and that is at the time the two pulses meet. Guys, this is all you have to do. How do you calculate this one? You will get 2 plus minus 3, the one at the bottom is negative, and that will give you minus 1 centimeter, which is the case there. So that is question 1.3, and I hope it's clear. That is what we call destructive interference in pulses. Let's go to the next question. The following wave pattern show a transverse wave. The wave takes 0.8 seconds to complete the pattern from A to F. And let's quickly mark here or see how many waves are from A to F. So if we're starting from A and we're going to mark only one wave, all this way here up until this point will give you one wave. So that one is one wave, and from there on is another wave. So in this pattern, guys, there are two waves. In this picture, there are two waves. And let's write this one here, because maybe we need that little space there to complete the pattern from A to F. You can see that the maximum height from B to the bottom here, this one here is 14 centimeter, and that the distance from A to F is 1 meter, given in the picture there. Now use the pattern to identify a point that represents a trough. Remember, the trough are points at the bottom, so in this case will be B and E. Those two represent a trough. You select either of them, so I'm going to write C or E. Either of them represent a trough. Okay, now a point that represents a crest. The crests are the points on top. Let's first use the opportunity and write there are troughs here, and then the ones on top, these ones are the crest. Those are the crests, and will be B and D, either one, B or D, either one. A point that represents a position of rest. Now the position of rest, you should remember, is any point that pass that straight line there. This is the position of rest here. That is the position of rest. So the points are either A or F. So this one is either A or F. Those 2 points are at the position of rest. 2 points that are in phase. Remember the definition of phase, or points in phase. But in this case, points in phase will be B or D, or B and D, and C and E. Either one of those are points in phase. They have the same motion at the same time. So points in phase here will be B and D, or you can also say C and E. Either of those are points in phase. Okay, now 2 points that are out of phase is obvious points that have different motion at different time, and in this case the points that are out of phase will be a B and C, or could be a C and E, or could be a D and E, or could be C and D. These are points that are out of phase. Remember, there's videos on that. I will leave the link so you can go and watch it if you think you still don't understand this concept. And we're going here. What is the amplitude of the wave? Well, guys, the amplitude of the wave will only be the distance from the rest position to the crest, or from the rest position to the trough. This one here, guys, is what we call amplitude, or this one here is also called amplitude. And you can see the total distance is 14 centimeters. So the amplitude of this wave will be equal to 7 centimeters. They don't say to express it in meters, so it is fine in centimeters. 7 centimeters. Let's write it here. 7 centimeters. Define wavelength of the wave. And the definition for wavelength is the distance between any 2 consecutive points that are in phase. Now, what is the wavelength of the wave? When you come here, you can see that, remember, wavelength is the distance between 2 consecutive points in phase. So it will be the distance between B and D or C and E. However, the wavelength is the distance of one complete wave. In other words, it's the distance from A to this point, or from that point to that point. You have a total of 1 meter for that wavelength, for that distance of 2 waves. So if two wave, let's do it on this side here. 2 waves have a distance of 1 meter. 1 wave, which is equivalent to the wavelength, will have how much? So you're going to have a cross product here. This will be a cross product, and then you will have here that 2x is equal to 1, x is equal to 1, then x is equal to 0.5 meters. That is the wavelength. It's quite simple. So what is the wavelength of the wave? 0.5 meters. That is the answer. What is the period of the wave? Now, period of the wave, remember, what is period? Is the time for one complete wave, same as here we did just now. If two waves will take 0.8 seconds according to the data you have there, then one wave, how long will it take? And you do cross product again here. So 2x is equal to 0.8. X will be equal to 0.8 divided by 2, which is 0.4 seconds. So the period of the wave is 0.4 seconds. It's very, very simple. This one is 0.4 seconds. Calculate the frequency. Well, guys, you know frequency is equal to 1 divided by period. So if you substitute here, you have that is 1 divided by 0.4, and then the answer is 2.5 Hertz. That is the answer for the frequency. And the final part of this question is to calculate the speed of the wave And it's also very simple. Speed, there is many formula, but speed of a wave is equal to frequency multiplied by the wavelength. And when you substitute, you have that is 2,5 multiplied by the wavelength, which is 0,5 it was given before, and then the speed of the wave 1,25. That is the answer, guys. And with this one we finish question 2. Question is about sound. Sound wave coming from a tuning fork are caused by vibration of the tuning fork, which pushes against the air particle in front of it. The figure below shows the propagation of sound wave produced by a tuning fork, and you have the tuning fork and the wave pattern go forward. Question 3.1: a sound wave transverse or longitudinal wave? Explain your answer. And the answer for this one is longitudinal wave. You must know, or you should know by now, that sound waves are longitudinal waves. So why sound wave a longitudinal wave? Because the particles move parallel to the direction of propagation of the wave. So in this case here of the drawing, the particles move in that direction and backward, they move forward and back, but the propagation of the wave is all the way to the front. That is what happened here. Okay, now identify a point that represents a compression and a point that represents a rarefaction. Remember, compression, the particles are further apart, so in this case for compression could be either B or could also be a D. This one here represents a compression, as well as this one here represent a compression. So those two letters represent a compression there. Now which one is the rarefaction? Is the areas where the particles are further apart. So in this case the rarefaction are this one here and this one there. Those two represent the rarefaction. Those are the rarefaction as well as this one. Those 2 points represent a rarefaction. Define compression. Well, we just mentioned it right now. The compression is the region in the wave where the particles are close to each other. Let's write it down in this space here. Alright, so what is a compression? A compression is a region in a longitudinal wave where the particles are the closest to each other. That is what we call compression, and that one will be question 3.3 there. Question 3.4. Question 3.4, if the same sound wave is now propagating in water, and this is very important, it was in the previous question as well, question paper. How will the speed of wave be compared with the one in the air? Increase, decrease, or remain the same? Now remember, the sound depends on particles moving through particles there. So you're supposed to remember that the sounds propagate faster in solid than liquid and faster in liquid than gases. Why? Because of the distance between the particles. The closer the particles are, the faster the wave can propagate, the faster this particle can give the energy to the next one, and so on. So if the same sound wave now propagate in water, now it will move faster, so it will increase the speed. All you have to say in the explanation, so as we say here, you have to say that sound travels faster in solids than liquid and faster in liquid than gases. Guys, this is the end of question 3. Really easy. We're almost done. We're going to question 4, which is the last question of this little test of 40 marks for the grade 10. Remember, if you think that the video is helping you, don't forget to subscribe. It is really useful. We distinguish between 7 different types of electromagnetic waves. These waves are travel at the speed of 3 times 10 to the 8 meters per second, but have different frequencies, wavelengths, and energy. The arrangement of these different electromagnetic radiations is called electromagnetic spectrum. And the first question say, name the type of electromagnetic radiation that has the highest penetrating ability. And out of all electromagnetic waves, the one that has the highest penetrating ability will be the gamma ray. Gamma ray will have the highest penetrating ability because it has the highest energy as well. It has the highest energy, and it has the higher energy because it has the highest frequency. Explain your answer, and that is almost what we are saying here. So the thing is, it has the highest frequency. It has the highest frequency, and if you remember, energy is going to be equal to H multiplied by frequency. Now, according to this formula, the one that have the highest energy will have the highest penetrating ability, and the energy is straight related to frequency. Higher frequency, higher energy, and therefore higher penetrating ability there. Mention one use of this type of radiation as well as one danger of it. Okay, for this answer, I'm not going to write all of them, but there are some important uses of gamma ray. So high doses of gamma ray are used to kill cancer cells. So they can be used to kill some cancer cell. However, that is also one of the dangers of it. It can produce cancer. So uncontrolled exposure to these gamma rays, guys, can give you cancer, but in a controlled environment it can be used to kill cancer, but they can be used for other things. So please, you can search for the information about the uses and danger of the gamma ray. Remember, this question is very interrelated. If you make the mistake at the beginning, then everything is going to be wrong here. And we're going to do the last one, 4.4. Another electromagnetic radiation have a wavelength of 0.02 nanometers. Remember, in this case you have to multiply by 10 to the minus 9, that is to convert. So from nanometers to meters. So for instance, this is the wavelength is equal to 0.02 nanometers, but when you convert will be equal to 0.02 times 10 to the minus 9 meters. That is the conversion. You have to work in meters. Calculate the energy of the photon of this electromagnetic radiation. So you go to the formulas, guys, and the formula you are going to use is E is equal to H multiplied by C divided by wavelength. So that is the formula we are going to use, and then when we substitute, H is a constant that you have in your exam, 63 times 10 to the minus 34, that is the value for H. C is a constant, it's the speed of light in the vacuum, is 3 times 10 to the 8, so everything is given, and the wavelength is given to you is 0.02 times 10 to the minus 9 meters. And when you calculate this one, guys, the energy is going to be equal to, the answer I get is 9.945 times 10 to the minus 15 joules. This is the energy I get. You can always recheck the calculation, but the calculation are not the most important part of this. Okay, guys, and this is the end of the video. This is a test you can practice. It's a test which have only, let's say, 3 topics, which is pulses, a wave, transverse wave, longitudinal wave, or sound, and it have 1 question on electromagnetic radiation. The question you will have at the end won't be that much different from this one, but thank you for watching. Good luck. I hope it helped. If it helped, please subscribe for the channel. I'll see you next time. Mr. G here.